In this video, we are going to discuss about problem solving. We want to solve a problem on three-phase systems using a 2-wattmeter method to find the readings of each wattmeter. This is for balanced loads. So the question says, this is our question, two wattmeters connected to a three-phase motor indicate the total power here to be 12 kilowatts. Then the power factor is 0.6. Then you are asked to determine the readings of each wattmeter. So you are given the total power to be 12 kilowatts. And we said to find the total power in a 2-wattmeter method. To find the total power is given by P1 plus P2. P1 plus P2 gives you the total power in a 2-wattmeter method. So we have our total power as 12 kilowatts. So we have our P1 plus P2, giving us 12 kilowatts. And then we are given a power factor of 0.6. We are given a power factor of 0.6. So when given a power factor of 0.6, and we have our formula to find the power factor as tan of phi is equal to the root of 3 into brackets the power 1 minus power 2 divided by power 1 plus power 2. That is how we find the power factor. And our power factor is 0.6. So to find our angle phi, it is the cos inverse of 0.6 to get the angle, which gives you 53.13 degrees from our calculators. It gives you 53.13 degrees. That is our phi. So replacing our tan phi, replacing our phi in our equation, our phi in our equation of tan phi, it gives you tan of phi, that is tan 53.13, tan phi, that is the tan 53.13. It gives you 1.33. It's a recurring number, that is 1.33. So replacing 1.33 in our tan phi, it gives you 1.3. Is you replace the values in your formula. So 1.33 is equals to the root of 3, P1 minus P2 divided by the denominator P1 plus P2, our total power to be equal to 12 kilowatts. That is what you replace in P1 plus P2, and you get that from our equations after replacing and after substituting. So when you open the bracket, you have P1 to be equal to 12 into 1.33. That is cross multiplying. When you cross multiply, you have 12 times, when you cross multiply, you have 12 multiplied by 1.33. Then you divide by the square root of 3. It gives you P1. When you divide from your calculators, and multiply, when you multiply 12.113 and divide by root 3, it gives you 9.237 kilowatts, which is equal to P1 minus P2. So when you add equations 1 and 2, equation 1 was P1 plus P2. This was our equation 1. P1 plus P2, which is equals to 12. And the P1 minus P2 to be equal to 9.37. When you add the two equations, so let's add the two equations. We have P1 plus P2, be equal to 12, and P1 minus P2 equal to 9.237 kilowatts. When you add the two equations, 12 plus that, so you have 2P1 will be equal to 21.237. Then you divide both sides by 2. P1 gives you 10.62 kilowatts. And P1, when this is our P1, from our formula, finding the total power, PT is equal to P1 plus P2. And we are given the total power as 12. And now we have found P1 as 10.62 kilowatts. Now plus P2. Now we don't know P2. So when you bring 10.2 0.62 to the left side, you have 12 minus 10.62 equal to P2. So when you subtract the two, it gives you 1.838 kilowatts, and that is the power, in P2, or in wattimeter 2. So the question asked us to determine the readings of each wattimeter, and we have already found the readings of the two wattimeters. P1 being 10.62 kilowatts, and P2 being 1.38 kilowatts. Those are the readings of the two wattimeters. Those are the two readings of the wattimeters.